This presentation will review the graphs of the trigonometric functions sine and cosine. This is the equation for the sine function. All of the variables affect different components of the graph. The A affects the amplitude, the B affects the period, and the equation for this is 2 pi over B. C represents the horizontal shifts, and just like any other function, these are opposite. So if it is negative, it will be a shift to the right, and if it is positive, it will be a shift to the left. The D in the equation represents the vertical shifts, so positive is a shift up, and negative is a shift down. This is the graph of the parent function for sine. This is the equation for cosine. All of the variables do the same things as they do in the sine equation. This is a graph of the parent function for cosine. It is slightly different than the sine graph, due to where it begins. It is important to know the difference between the two. There are 5 key points to every cycle of the function. These are the max and min points, as well as the intercepts of the midline. The 5 key points make up the starting point, quarter period, half period, 3/4 period, and full period. The 3 terms to know which will be discussed later are midline, amplitude, and period. The midline is halfway between the max and min points of the function. This is represented by y equals d. Amplitude is the distance from the midline to the max or min point. Amplitude equals the absolute value of A. If the absolute value of A is greater than 1, the amplitude stretches the graph vertically. If the absolute value of A is between 0 and 1, the amplitude compresses the graph vertically. If A is less than 0, the graph is reflected in the x-axis. The amplitude of the parent function is 1, until the parent function is graphed. In gray, the parent function has been compressed because A is between 0 and 1. In red, A is greater than 1, so the graph has been stretched from the parent function. In black, the graph has also been stretched. And in burgundy, the graph has been reflected from the black, because A is negative. This is practice to see how amplitude changes the parent function. When A is 3, the graph is stretched vertically by 3, and the amplitude is equal to 3. When A is 1/2, the graph is vertically compressed by 1/2, and the amplitude is equal to 1/2. The period is the distance it takes to complete one cycle of the function. This one piece of the function repeats over and over, causing the function to be periodic. The equation for the period is 2 pi over B. The period of the parent function is 2 pi. The period will horizontally stretch or compress the parent function. If B is between 0 and 1, the graph of the function is stretched horizontally. If B is greater than 1, the graph of the function is compressed horizontally. This is an example of the period changing from the parent function. In blue, the parent function is graphed. In red, B is 2. This changes the period to be pi once you put it into the equation for period. This shows if B is greater than 1, the graph compresses. This graph is happening twice as often as the original wave. This is another example of the period changing the parent graph. In blue, the parent function is graphed. In red, B was changed to 1/2. Because of this, when you solve for the period using B, the period is 4 pi. This shows if B is between 0 and 1, the graph stretches. This graph is happening half as often as the original wave. This is a graph reviewing the 3 terms just discussed. The blue shows the period, which is one complete cycle of the function. The red shows the midline, which is halfway between the max and min points, and the green shows the amplitude, which is the distance from the midline to the max and min points. Can you write the equation? First, you need to determine if it is sine or cosine. This is cosine. You know the amplitude is 2 because that is the distance from the midline to the max and min points. The period is 24 pi, because each quarter period is 6 pi. When you plug 24 pi into the equation for the period, and solve for B, B is equal to 1/12. Therefore the equation is y equals 2 times the cosine of 1/12 x. First, you need to determine if it is sine or cosine. This is sine. You know the amplitude is 2 because that is the distance from the midline to the max and min points. The period is 8 pi, because that is how long it takes to complete one cycle of the function. When you plug 8 pi into the equation for the period, and solve for b, b is equal to pi over 4. When you look at the graph, and compare it to the parent function, it is flipped over the x-axis. Therefore the equation is y equals -2 times the sine of pi over 4x. So far we have worked up to the equations below. We know a represents the amplitude, and b represents the period. If we translate the graph c units horizontally, and d units vertically, then the resulting equations are y equals a times the sine of bx minus c plus d, and y equals a times the cosine bx minus c plus d. When the graph is shifted c units horizontally, then x is replaced with bx minus c. Remember that a phase shift acts in the opposite direction, just like all other functions. In the graph to the side, the graph was shifted 1 unit to the right. When the graph is shifted vertically, then y will equals a times the sine of bx minus c plus d. The graph to the side was shifted 4 units up. What is the equation graph to the right? Because it starts at the origin, we know that the function graph is y equals the sine of x. What is the equation graph to the left? Because it starts at the max point, the function graph is y equals the cosine of x. Sine functions will start at the origin unless it goes through any shifts, and cosine does not. For example, sketch the graph of y equals 3 times the cosine of x on the interval -pi to 4 pi. First you need to find the 5 key points. Graph 1 cycle, then repeat the cycle over the interval. Because b is 1, we know that the period is 2 pi. Because there is no d, we know the midline is 0. Because a is 3, we know that amplitude is 3. From here we can plot our 5 key points. After you can connect them with a smooth curve, and then continue the cycle for the whole interval. Example, determine the equation of the graph below. First determine if it's sine or cosine. This is sine. The period is 2 pi, therefore b equals 1. The amplitude is 1, because that is the distance from the midline to the max and min points. The midline is y equals 2, therefore d equals 2. This graph has been vertically shifted too. Therefore the equations is y equals the sine of x plus 2.